Hello everyone. So this is our first stream. I'm getting used to the environment here, and so it might be a bit clunky as I go to transition from one scene to the next. So this one is about BINCO, and it's the next project that is going out to Boldport Club members in about 10 days' time. So it's all packaged up. Um, this in this pillow box they call it, and it's an up-down counter. And let me change the view. So this is the board. It's an up-down binary counter. You configure it to go up or down while you're soldering it. You have to decide because the orientation of the LEDs and some of the components and this little jumper, you have to decide whether you're going to how you're going to configure it in order for it to count up or down. Now, it has these really nice tactile domes that were donated by Snaptron that act as momentary buttons. And this particular one has two states, which you'll see functioning in a minute. And then there's another one here for reset. So let's see it working. So you turn it on, and then you count either slow or fast. This one is obviously counting down. And if you reset it, press this, you get all high, again because it's counting down slow and fast. And this one would be configured to count up. And press reset, it goes up. Now it has a 555 timer here and a 14-bit counter. And the button, this two-state button, controls the feedback to count either slow or fast. Now these buttons, I originally thought that you soldered them on, but these are just attached using an adhesive sheet that is supplied as part of the kit. So you just cut a piece and put it together, put it on the pad. Here's the unpopulated board, and you can see that there is the outer contacts for this one. There's 1 and 2, and the inner contact, which makes a contact either with the with this one or both. And obviously this one is a single contact between the outer ring and the internal one. Similarly here. So this is the board, and let's have a look at the website for this. We have lovely images. But the main thing, and that's what we do with every project, is provide enough information to get started. It's not totally comprehensive. It varies between project and project, but depending on the project, I create these infographics that provide the schematic and assembly information, leaving some of the details out for people to discover why things behave the way they do. So here we have the schematic and the LEDs, the choice between the LEDs and the whether you want to go up and down, some information about the assembly. There's also a curious thing about how this thing works. Let me go back. about how this thing works, and I allude to it in the infographic, but I'll leave it at for now, so people, when they receive it, they can figure out if you do certain things, it doesn't work as you'd expect. If you do things in the wrong order, it doesn't work as you would expect, and it's quite interesting to figure out why it does that. But you'll need a schematic and the data sheet for that. The other thing I wanted to show, these boards were made by Eurocircuits, and they're really nice. And while we're at experimenting here with this live streaming stuff, I wanted to show you the Microscope View. For some reason, it's a bit dark. Not sure why it's so dark. So you can't see anything. I'll have to work on that. I do have a torch here. Yeah, don't know what's going on. Well, it was working perfectly before. Oh. Well, what I want to show is that there is a part of the pour. There's a pattern of digits that may or may not mean something. So maybe you could figure that out as well. All right. So for next time, take a note to see why this isn't working very well. But all right. So I think this is a really neat surface mount project. We do surface mount projects every 2 or 3 projects. Some of the devices that we want to use don't come in through-hole or dip packages, so never want to exclude using interesting devices. And I think that's it for this introduction. I may in the future, maybe next week, do a soldering session of this board. By the way, it's battery powered, and when it's off, that is when you're not pressing this button, it's consuming between 60 to 70 microamps. So on a single battery, it should last for quite a long time. Of course, when the LEDs are on, there's there's more current going through it, but it's not meant to be used constantly. And you can learn a little bit about reading binary, which is mildly useful in day-to-day life. But that's it. All right, see you next time.